Welcome! This is a quick user guide for using StingerStudio. The basic idea of this video is to showcase how easy it is to actually route your two-stroke exhaust design to fit your frame. First, we design the exhaust diameter profile, then create a route and ultimately get flat patterns for cones that will fulfill your profile whilst following the defined route. Let's start with the profile calculator. In this example, we're dealing with 250 ccKTM. I'll just quickly input some input values out of my head. When we're satisfied with this exhaust profile, we can save it for later usage in the route editor. Let's create a new project and name it. The project will be automatically saved after naming it and after every change to the project. And now this project appears here in my projects. There are a few example projects here, and these can be used to familiarize yourself with the user interface. In these menus, every component of the view can be hidden separately. If you want to look at just the parts, you can do it like this, for example. And if you want to look at the routing, then this is the menu. You can see the original designed route and a discretized version that has been built from straight lines. And we can modify these route parts here separately in the editor. So for example, these two bends here, they have a small difference, and it's due to that roll setting. Let's remove those example projects and continue with the KTM exhaust. So by default, the project has only a straight pipe, and it's a placeholder for whatever will be done with it. Let's turn off all part visibilities. Let's also hide the discretized route, but keep the others. I like to turn that off too. Now we can import some external geometry, that is a 3D scan or model of the motorcycle. In this case, the model unit is in meters. And now we have there a model bike, based on which we can make this exhaust pipe. Let's find a reasonable rotation for that bike. Let's adjust it to the right height. The height of this floor level is actually determined only by that exhaust pipe, not from this external geometry. And our next task is to match this starting point to this exhaust pipe starting point. So let's find appropriate values with which it would be close. We can also rotate it. So in this case, we need to rotate it along two axes. The axis marker always shows the last point of the route, so now the route is wrong way around. I've sped up the video here a bit, but it only took me a few minutes. I try to position the route start point as well as possible. It is critical to get this right. All right, I think this is good enough. The position looks good, and so does the angle. Now we can then modify this route. So first of all, let's shorten that straight section. After that, let's add a bend there. I like to use the interactive controls for bends, but you can also do this numerically in the right column. The yellow handle controls the roll, the magenta is for the bend radius, and cyan is for the bend angle. And as you saw, straight sections only have length and roll control. I'm just trying to follow that pipe center line here as well as possible. This can take some time to get used to, but in the end, the controls are really easy. Occasionally, I like to take a look at the route, just to verify it still looks sensible. I've sped up the rest of the routing process, but the whole route from this original exhaust took me less than 10 minutes to trace. And it seems like we're done with the routing. This is how the bare route looks like without the external model. Now I'll swap the model. I have the same model, but without the factory exhaust pipe. I've removed it from the scan using Blender earlier. I just had to set the correct coordinates we set for the model geometry earlier. Let's turn the parts on. So here you can see that 200 millimeters placeholder pipe routed using the route we just created. We could just use this profile if we wanted to make a constant diameter exhaust like this. We can of course modify the profile manually from here. Let's alter some values. And now it's thicker from here. Even this thick. And this resembles quite closely that original pipe. There are just quite tight bends here. And now, in this case, these two pieces of bends around this part are determined by this route section, and we can adjust a smaller discretization angle value to it, whereby we get finer angles there. We can adjust angles separately for these route sections here. So as an example, let's change the maximum discretization angle value for this section. And it gets split to more parts. This, of course, means more welding, so you'll have to do a bit of manual optimization here. Here there's a slider that changes everything at once, but it is overridden by the section-specific settings. And now the magic. Let's import here the profile we designed at the beginning using the calculator. So this is the loaded profile. And it would look like this. And with the external geometry like this. Now we notice that it doesn't quite fit there. So what we can do is modify the route. For example, by increasing this bend's radius, it also moves all subsequent route points outward, and so on. We can bring it a bit this way. And we have included here the stinger. We can modify it to, say, 1,250, whereby that pipe indeed ends before this profile. The exhaust is only drawn as far as that route or diameter profile extends. So if I add a straight section there, but if this straight section is shorter, then the pipe is only drawn that far. In addition, each part can be examined separately. And the flat pattern for each part can be seen here. Each part has separate seams, and the seams are automatically optimized so that they're at the shortest welding length. Usually that means on the inside of the bend. However, if you want, that seam can be moved on a per-part basis to different locations. And in addition, there's a small marker visible here that shows where the previous part's seam ends. In this case, the previous part's seam is there. So in this flat pattern, the marker would correspond to the previous part's seam location. If we move the parts' seam to that same position, then the alignment marker is also there on the seam. The marker is exported on separate DXF layer, in case you have access to a laser cutting machine that also does markings. From here, we can restore again that optimal setting to the shortest seam location. Adjusting the seams can be quite useful if you want to move a certain part's seam, so it is, for example, continuous, or hide the seams in such a way that they're not visible. In addition, it's possible to turn these marks on and off here. And also in this 3D view, you can turn on these marks showing where the previous part's seam is located. So for example, for this part, the previous part's seam mark is there. And correspondingly, here, its mark is there. Parts can be exported one at a time as DXF, all parts as DXF, as STL for 3D printing, or then as a complete pipe. This is useful for test fits before committing to sheet metal work. Even after generating the parts, you can still modify the profile and the view will be updated live. Say we want to reduce the belly diameter like this. Or maybe we want a smaller stinger. And individual part details are shown here. In addition, there's material compensation on and off here. So in practice, it adds material thickness equivalent to both diameters here. And now when it's on, you can see that it adds 2 millimeters per side there, and when we turn it off, it removes it. So, just to repeat, say we've detected an error here. The exhaust goes through the frame there. We can fix this by adjusting our route. Let's make the bend radius larger there. We can modify it either from here in the route editor or interactively from the 3D view. And we see that it updates. Like this. And now the exhaust avoids the frame at that point. The whole thing didn't take an enormous amount of time, and as a result, we have an exhaust pipe that's exactly the correct shape and fits our frame geometry perfectly. There's no obligation to use this external geometry. We can remove it completely. In that case, it's advisable to take precise measurements of the geometry beforehand. That's it. Thanks for watching.